So you have this kind of functions that work properly for the consensus that you're trying to handle it. So let's zoom this, have a better view of this. And let's move this a little bit more. And you can find here that this recovery for the letter, it's all about to persist the consensus, to persist the blocks, to persist the certificate thing. So you start to think in persist the highest time of certificate to improve this liveness. Remember that is the way for build this BFT implementation. So far you need to think in membership, and this membership is you have the highest thing and you also have the slowest thing. So you need to construct this function for make this different. So in the condition of the protocol specification, the highest is because you are dealing with the longest chain. So this longest chain have the highest time observed. So makes sense in these two kind of instance. So you have the function of save highest times observed. So far is the self of the highest time observed, and this time out certificate is the result of the highest. So far you have that the percentile liveness storage have these 5 functions. It's all about to persist the block and certificate and persist the safe state, then recover the data that you are handled. They make this properly membership thing that is save the highest time observed. And so far you have this liveness thing, and it's essential for maintaining the blockchain approach when a node crashes, specifically on the star, a current node will recover. So you can find out there a lot of literature of handle Byzantine crash, Byzantine failure, sorry, and also the crashes that any kind of BFT protocol has. But remember that these blockchain thing are value, money value, so this is not good that crash this system. So let's move to see more things about this persistent liveness. And see the thing that is for the other instance that you can have. So far you can find here the ledger recovery data. So you are debugging this boogie function. So this is only technical way to make the first fix here. also you have the liveness mechanisms. So liveness here in the protocol specification. New commits are produced as long as valid commands are submitted. Note that nodes should observe commits in the same order, but not necessarily in the same time. So far, you are dealing with the commits that this kind of log valid commands are submitted. So in a practical way for develop a code, you need a lot of expertise of handle storage. So see more things here. I don't know. So this is all about the technical way for Saudis. And it's all about the EPR's client side. This EPR's client side is a thing out there for communication. That is a kind of protocol. So far, this liveness storage handling that kind of approach, but also have the highest time assert. That is the way for handle it, connect these two kind of protocols things. So it's an elegant solution for connect this liveness storage, and how this storage is connect. So let's see interesting things here. For example, find blocks to prune. Make this function that is in the way of this, then that you are recover the data, so you need to prune the things. So let's make a function here for this condition. So define blocks to prune. So the things other data that this have is the root ID, that is a hash value. You also have blocks. So move back block. In this block you have the same input of the state machine replication and remember that it's an key of the key insert. This key insert will be a vector, the hash value. So let's see to print this. So let's 3 of the hash set new So this is the way for the function to handle this block to prone. Remember that in summary you need to persist the consensus state, you need to persist other modules that are not properly handled. So basically you need to remove this. So then insert the things that you don't need. So it's like this Lego thing. Makes sense. Then these blocks needs assume that the blocks are sorted by round already. So this is the hard part, figuring out how to prune these blocks in a technical way for dealing with the protocol specification and obviously leading with the personal connect asynchronous network. So the blocks statement of the tree contains obviously the block parent, because remember that you have parent shields in this tree Merkle tree sense, that is a variant of the Merkle tree. So this tree insert block ID. The idea is for protect the resilient thing in the way of the membership needs. So true. Other condition. So you need to vend this. So remove the page block ID. Another condition is the thing that you don't need, so false. And so far you pruned the blocks. So the hard part is to compile this. So, but you have the protocol specification, but also you have the paper up there, and you also have the literature up there, and a team that have a different kind of expertise in some areas. Maybe there is a person in the team that are doing very good build in the prune thing. So maybe you can try a script in Python, then make this flipping in effect in the Rust way. So there's a lot of work to do and a lot of fun here. Yes, so let's move to see about the quorum side. So the quorum cert, so runtime of the quorum. So also you have the tree. Remember that it's the variant of the Merkle tree. So also contains qc cert duplicate. So in the same way you need to remove the thing. So far you have that. So we saw to persist the consensus state with summary the persist of the liveness stores if a node will crash. So you need to prune this in a safety way that needs this membership thing. So far you have rounds also and leaders in any kind of round. So you need to justify a thing here as the way that could be connect on the node acts as a leader, so the node is protection for any kind of adversary of any kind of failure, resenting failure. So let's see in another video. I'm figuring out more things about the liveness.